So in section 3.4, we're going to be graphing linear equations, which means what? Straight lines. Okay, we're going to be graphing things that are straight. We're not going to graph curves or anything else like that. Okay, straight lines. So one way we've graphed lines before is with a certain equation. Does anybody remember that equation that starts y equals? We're not going to do that one today, but we've done it before. Yeah, we've done y equals mx plus b. Okay, where m is yours, anyone remember? Slope. And what's b? That's the y-intercept. Okay, that's called slope-intercept form. Okay, and we've done a little bit with that in the past. Today we're going to look at a different form. It's called standard form. Okay, so on your notes where it says the blank of a linear equation is, in the first blank fill in standard form. Okay, the standard form of a linear equation is, and then the next two lines you get some blanks. You want to copy everything you see below it. This is the equation of standard form. Okay, it's ax plus by equals c. Okay, and what we generally do is we fill in numbers for a, b, and c. Okay, they'll give you some numbers to put in there. There's only one thing you're not allowed to fill in. Okay, you can't have a and b both be 0. One of them can be 0, but a and b can't both be 0. Okay, so let me show you, let me just write down an example of an equation that's in standard form. 3x plus 2y equals 6. Okay, that's an example of an equation in standard form. Okay, so if you look at what I just wrote, what did I fill in for a in my equation? Yep, I filled in 3, and then for b, put in a 2, and then c, filled in 6. Okay, so that's what our equations are going to look like today, and I'm going to show you how to graph something like that. There's two ways to do it. One way is to take this and change it back to the other form that we know. What's that other equation? Y equals mx plus b. So we could take this and we could change it to that. Okay, but that's going to be extra work. So I'm going to show you how to keep it just like this and graph it the way it is. All right. What can't you recognize in that equation as easily as you can if it's like this? There's something you could tell if it was written like this very, very quickly, but you can't tell here. You can't tell what the y-intercept is. That's one thing. And what else can't you see? M. I don't know what the slope of this is. I have no idea. Unless I take and I rewrite it the way we did before. Okay, so that's kind of a disadvantage of this. You don't know the slope in the y-intercept by looking at it. But there's some other reasons why it is easier to use for other things. All right, so we have two special cases. Okay, what kind of lines have we studied that usually they're special cases? Anybody remember? There's two special cases of lines when you draw them. How about when you have a line with a special slope? What's a special slope you could have? What number? 0. Yeah, that's one special case. Anybody remember what kind of line, if it's not going up or down, it's a slope of 0? What kind of line is that? So I'll come back to undefined. I want to talk about that. That's something else. But when you have a slope of 0, it's not slanted up, it's not slanted down, it's straight. Well, this is straight too. It's straight, still straight.
Vertical or revolution or all?
Somebody else said something. vertical and horizontal. All right, so those are the two special cases. Okay. So under special case number 1, they put down if you have an equation of the form, and then the part that's in bold, that's what you need to write down. If it's y equals a number, that's a horizontal line. Okay, and where would you put the horizontal line? You put it right at the number they tell you. Okay, so there's an example of a special case. Let's kind of compare that to what I wrote up above. Ax plus by equals c. Where's the x in this formula? Y equals 3. Well, Liam, do you see where's the x in y equals 3? Like I see the x right there. There's the x. It's right next to the 3. No, nothing after the 3.
There is none?
There isn't one. So if there is no x, what would you have to put in for that number to make x just disappear? Think of what you could plug in for a, so when you multiply by x, it would be gone. 0. Okay? So in this problem, it's like a is 0. Now, what's the number in front of y, even though it's invisible? It's like having a 1 right there. So the number you put in front of y, what letter is that up above? It's the b. Equals, and in my equation in red, what number is on the other side?
3.
3. So in this equation, y equals 3, this really is standard form. But it's like you're letting a be 0, so this part gets wiped out. You're letting b be 1, and then 1 times y is just y, and you're letting c equal 3. Okay, so that's where it kind of confuses people. When one of the letters disappears, it's because you either let a or b be a 0. Okay, and we'll try one of each. All right, so y equals 3. What kind of line is that going to be? It's a special case because there's no x. If I draw that, what kind of line, Josh? What kind? Yeah, it's going to be a horizontal line because it says anything that's of the form y equals, just like this, y equals a number, is horizontal. And Derek, where is it a horizontal line? At what number?
3.
3. Yeah, it says right here, y equals is horizontal, and it's at the number 3. Okay, so if you were going to sketch it, that's how you would sketch it. Okay, so you've got a spot on your guided notes, okay, where you can fill that in. Okay, so just draw a horizontal line right it through. And in fact, you know what? We don't have any extra grids on the front, so I'm going to have you reuse these grids for another problem too. Okay? But what I want you to do is once you put the horizontal line, label it right next to it. Because we're going to draw another line on here, and I'll have you label that one too. Okay, so you can get rid of the x and just have the y. Okay? No x. But instead of just having a y by itself, what other letter could you have by itself? Yeah, you could have something that's like this. Okay, x equals 5. Okay, and that's another special case. Okay, the reason why it's a special case is because you only have one letter. Okay? No, you don't have both. Okay? Usually what happens when you have both letters, you have the X and the Y, is you end up drawing a line that's slanted. Okay? When you only have one letter, it's either going to be a horizontal line
Do we have tissues?
or a vertical line. Yeah. Okay. Any questions on that one? Okay, so that goes right down under number 2. Okay, on your guided notes. Okay, so x equals 5. Okay, when I sketch this, what kind of line is x equals 5 going to be? It's going to be vertical. How do you know that? Yeah.
Because you're putting on that x-axis? Like you're following the x-axis?
Well, x-axis goes left and right.
Oh,
You have to go through it.
So how do you know that this is a vertical line, though? Why not horizontal? Yeah. If it's y and just a number, that's horizontal. If it's x and just a number, okay, that's your vertical. So yeah, x equals is always vertical. So in this one, where am I going to put my vertical line? What number would we put it at? Yeah. Yeah, you're going to put a vertical line at 5. Okay. So I tried to show you where it is. It's x equals 5. Okay, so on your notes on the second grid, just draw that line in and label it just like I did right above it. Okay? And I'm going to have you reuse these 2 grids for the next problem. Okay, we'll just draw on them again. Now, most problems you guys see on the test, they're not going to be just x equals a number and y equals a number. Okay? They're going to look more like that. They're going to have an x and a y. So we'll talk about how do you graph it when it's an x and a y. But for now, let's just try graphing it when all you have is one letter. Either x or y. All right, so let's try this one. All right, so what you can do is use the same grid you just used. Use the top grid again. Okay, so you already drew a horizontal line there. We'll do another one. All right, can anybody tell me what kind of line is this? It's a special case because it only has one letter. But how do you know it's the horizontal? How come this one's not the vertical? Yeah, because it's y. Anytime you see y, that's a horizontal. And how do I know where to put it? Because I could put it lots of different spots. Yeah, you put it at the number. Okay, so take your line and just make sure we put it 1, 2, 3, 4 units. Okay, so on your notes on the front page, you can just use the top grid again. Okay, you already have, what's the other line we drew that was horizontal? Y equals? All right, so this one's just right above it. Okay, so now you got 2 examples. Okay, so even though it's a special case, it's probably one of the easiest ones to do. Okay, because you don't really have to do any math with it. Okay, all you have to do is draw a horizontal or vertical line. Okay, any questions on that one? All right, how about this one? Okay, first thing, is this a special case or is this a normal one? How do you know it's a special case? I agree with you, it is a special case. It's only one letter, right? It's not a problem like this one or that one. Okay, if you see the X and the Y, we're going to have a different way to do that. But if you only see one letter, like that or that, it's a special case. Now we got to decide, is it the special case where it's horizontal or vertical? Yeah. X equals. Okay, that tells you it's vertical. I know the x-axis normally goes horizontal, but you just have, this is just how it works. X equals is vertical. Yeah, question, Antonio?
Is it like 100% of the time X will always be vertical?
Yep, X is always vertical.
Like there's no special case?
No special case. X is always vertical. Every day of the week that ends in a Y. Yep. All right, so what, where do I put that vertical line? Go to the left, how many? 2. Okay, so take your vertical line, put it at X equals -2. Okay, and just label it, okay, right above it. The reason I label it is because sometimes, especially on my smartboard, I think the axis and the line can look the same. I could also just make it a different color. So X equals -2. All right, so any questions on the special cases? Okay, somebody give me a line that would be horizontal. You tell me the equation of a line that would be horizontal. Well, it's got to have more than just a number. Y equals 5. Perfect. How about somebody give me an equation of a line that would be vertical?
X equals
X equals what?
184.
184, sure. Okay. As long as it's X equals, there's your vertical.
X equals 203.
All right, so the next thing we're going to look at, okay guys, next thing we're going to look at is lines that are not a special case. Okay, basically lines that are slanting, okay, on a diagonal.
What page is that?
This part, you're just going to watch this part. I'll let you know when you have to write something down. Okay, if you're going to draw a line, how many points do you need at a minimum to draw a line?
1. No, 2.
You're going to have 2, right? Because if you only have 1 point, how many lines go through that 1 point?
A lot.
Yeah, you can draw any line that goes through it. But what if I put 2 points?
Oh.
How many lines would go through those 2? Only 1. Okay, so you only need 2 points, okay, to draw a line.
Well, technically, if you think about it, you said go through. If you went through, you could still go through the middle and you'd be in between the lines.
So you think you can draw more than 1 line going through those 2 points?
Oh, no, I was joking.
Oh, okay. All right, so that idea of finding 2 points, that's how we're going to graph equations in standard form. Okay, we're going to find 2 special points. Jody, what are we going to find?
2 special points.
Very good. Okay, the 2 special points we're going to find are called the intercepts. Which one of these have we done before? Y-intercept. What's the y-intercept? What does that mean?
The point which the line crosses through the y-axis.
Right, it's the point where the line crosses the y-axis. Right? So if I had my axes like this, and I drew that line, that's my y-intercept. Right there. What about the x-intercept? What's that? Yeah. Yeah, it's where it crosses the x-axis. Okay, so we're gonna try to find those 2 points. Okay, if we can find them, that's all you need to draw a line. Okay, where does it cross the y-axis? Where does it cross the x-axis? What's special about those points? Vanessa, what's special about those points?
They're very special because they only have one line.
Well, about an intercept. What's special about an intercept? Yeah, Liam.
Because it crosses through the x and y.
All right, let's take a look at this. Okay. If I wanted to know the coordinates of that point, this coordinate is definitely going to have a certain number in it. It's going to have a 0. How about this one?
Oh, so they're both zeros.
They're both going to have a 0 somewhere. Okay, maybe this one is like 0.5, and this one is 0.4. I'm sorry, 4.0. But the point is, anytime you're finding an intercept, it has something to do with the number 0. Yes. All right, so now on your notes, okay, this is where you want to start writing stuff.
On the back?
Nope, right on the front at the bottom.
You know what, Antonio?
Okay, so where it says crosses, and then you guys have a blank, you want to fill in what's in bold. Okay, the x-intercept is where the graph crosses the x-axis. And the y-intercept, that's where the graph crosses the y-axis. Okay, and what number did I say that the intercepts have to do with? 0. Okay, so now I'm going to show you how you find each intercept. And once you find where it crosses the x-axis and where it crosses the y-axis, then you can just draw a line a little better than that, right through those points. Okay, and that's your line. Okay, so to find your x-intercept, okay, you want to plug in 0 for y. Okay, so on your notes at the bottom where it says to find the blank, to find the x-intercept, plug in 0 for y. Okay, and you're going to solve for x.
Find the y-intercept. Plug in 0 for
Yeah, can you be quiet?
Yeah, go ahead. How do you think you're going to do the y-intercept?
Opposite of that.
So what's the opposite?
So
Find
Zero.
y-intercept, you plug in 0 for x and solve for y.
Yep. To find the y-intercept, plug in 0 for x and solve for y. Okay, what usually throws people off with this is to find the x-intercept, you're plugging 0 in for y. And then to find the y-intercept, you're plugging 0 in for x. Okay? So you just make sure you remember that, and that's probably a good thing to put on your reference sheet. Okay. Questions on that? Okay, does everybody have that copied?
I'll do it after.
We're good?
Yeah, I'm good.
Anyone else need to copy it? All right, so I want to graph this line. Okay, one way I can graph it is, you guys already learned a couple weeks ago, we do y equals mx plus b. That's different. Okay, I want to graph this in standard form. 3x plus 4y equals 12. Is it a special case?
No.
Why not?
Because it doesn't have only one number.
It doesn't have just one letter, it's got both. If it's got both, that's the normal case. Okay? If it only has one letter, we just did those. So, let's say I want to find my y-intercept. Okay, so on your notes, you should have a spot on the back where you can write this in. Somebody tell me how I find the y-intercept.
You plug in 0 for x.
Okay, so you're going to plug in 0 for x right there. Okay? Keep everything else the same. Just plug in 0 for x. So once I do that, who can tell me what that's going to look like? Just change that one thing and keep everything else the same. Yeah, Nina? 3 times 0 plus 4y equals 12. All right, now I filled in 0 for x. What else do the directions say to do?
Can I do that?
Yeah, just sign out.
Oh, no, wait, and then solve for
Y.
y.
Solve for y. Okay, so let's simplify it. What's 3 times 0?
0.
Okay. Anytime you're finding an intercept, that's always going to happen. One of the numbers is going to cancel out. Okay, so what am I left with?
4y equals 12.
4y equals 12. And now how do I get y by itself?
You divide 12 by 4.
Divide both sides by 4. So what do I get for a y-intercept?
3.
I get y equals 3.
So x is 4.
So how do I graph that? What is y-intercept again? Vanessa?
No, this way.
What is that?
Wait, that is horizontal.
It's what?
Horizontal.
No.
Well,
No.
it's an intercept. So an intercept is a point.
Oh.
Where do we put that?
On the y.
On the y-axis at what number?
3.
3. So what you're going to do is put a dot on 3, okay? Because that's your y-intercept. Now, I need one more dot to draw the line. What's the other dot that I'm going to find? What's the name of it?
The y.
It's the x.
X-axis.
The x equals 4.
What's it called, though?
The x-axis. No.
Intercept.
Intercept. Got it.
Okay, how did you get 4, Emma? What did you do?
I did mental math.
All right, what did you do in your head? How'd you do it?
I know it was in my head, so.
You're not sure what you thought about?
Well, I know I'm pretty sure it's 4 because you do what you did for the y, and yeah. When you divide it by 3, it's, I don't know what I'm saying.
So how do I get that y-intercept? It is 4, but what's your equation? What do you plug in? What did we say back on that other page? Well, how do you find the x-intercept? Okay?
You put the 3 where the y is.
We have to plug in a certain number. Where do you plug in the 0? Plug in 0 for y. Okay, so can somebody tell me what that equation will look like if I do that?
4.
Something before that, because you got one term before the y, right? Eastley's? Yep, 3x plus, fill in 0 for y, so 4 times 0 equals 12. Okay, so we get 3x plus 4 times 0 equals 12. What's 4 times 0?
0.
So notice this time, the 4 is the number that's gone. Last time it was the 3. Each time, it's always going to be a number that disappears. Okay? What am I left with on the left-hand side? And right? 12.
Equals
And now this is how you get 4. Okay? Divide each side by 3. And 12 divided by 3 gives me 4. Okay, so how do I graph that? Yeah, we're going to graph the number 4 on the x-axis. Is that to the left or to the right? To the right. Okay. And now, Vanessa, can you sit up there for me? Thank you. So now we've got 4 on the x-axis. Now I've got my 2 dots, but what's the last thing I got to do?
You gotta draw that line.
Yeah, just draw that line. And there's your points. And that's it. Okay, so graphing an equation where you have to find the intercepts,
Wait, that's it?
that's very simple as long as the numbers come out nice. You can get fractions here. If you get fractions, we'll just use a calculator. Mhm.
Wait, we never fraction. You want us to turn into decimals or just keep them as fractions?
Yep, we'll write it as a decimal. So if you get like 5 divided by 2, we'll put 2.5. Yep. Okay, any questions on that one? All right, we're going to try another one, but keep in mind sometimes your numbers get kind of big. So if the numbers get big, what we might have to do is instead of going by 1s, we might go by like 5s or even 10s. Okay? So in I think the next problem coming up, we might have to adjust a little bit. We have 2b first. Okay, on your guided notes, I don't think you have a spot for 2b. Okay, so just follow along and try to help me to do this one. All right, this one looks a little different. What's the number in front of y? 1. Okay, so it's 2x minus 1y equals 4. Okay, someone tell me how do I graph this? What should I do first? Yeah.
Make the y a 0,
All right, and if I do that, what's that going to find for me?
the x.
The x
Intercept.
intercept. Good. So I'm going to do exactly what Antonio said. Fill in. Go ahead. You tell me what to do.
Okay. So after that, it's 2x minus 1, and then parentheses 0, and then equals 4.
Equals 4. Perfect.
So you got 2x, and then you do it 1 times that 0, so 2x equals 4.
Yep. Negative 1 times 0. That's gone.
And then you just divide 2 by both sides, and you end up with x equals.
Are we writing this down too?
X equals 2. This one, if you have room, you could put it right in the same area that you did 2a. If you don't, that's okay. You could just watch me do it, but I wanted to show you because it looks a little weird, because it looks like there's no number in front of y, but there is. It's a negative 1. So, where do I put that x-intercept?
On the x-axis,
On the x-axis? Where?
on the right side, 2 over.
Yep.
Right there.
Now, if all I have is that point, is that enough to draw my line?
No, it's not.
No, because I don't know if it goes like this, or like this, or like that. I don't know yet. So I got to find one more point. What's the name of the other point I got to find?
The y.
The y-intercept. Okay, can somebody else tell me? How do I find where this line crosses the y-axis? What do I have to do for that? I've got to fill in, think of what number we work with. So what are you filling in? You're filling in for the x, I like it. And what number did you fill in? Perfect. So just fill in 0 right there. So 2 times 0 minus, you can put minus 1 times y, or you could just put minus y. And can somebody remind me what's it equal to? It's up off my screen. It's equal to, you want to copy it? No, equals 4.
Is there still a 1 in front of that y or no?
Yep, you can put the 1 there if you want.
Okay, so B.
So now what do I do?
Make the 0 because 2 times 0 is 0.
2 times 0 is 0, that's gone.
Negative 1 y equals 4.
Yep,
Negative y equals
yep. And now, how do I get it y equals? I don't want negative y equals.
4. Divide 1 by both sides.
Careful, not 1, but close.
Negative 1?
Yeah, negative 1. When you divide a negative by a negative, what do you get?
Positive.
Positive. And what's 4 divided by negative 1? Negative 4. So, Ashley, can you tell me how I graph that point? Yep, and how do I get there? Go on the y-axis and just go down 4. Perfect. And so I got my 2 dots, but what's the last thing I got to do?
Yeah, graph is.
I got to, draw the line right through those points. Okay, so just draw it the best you can. And that's pretty good. Okay, so that's all there is to graphing a line with the intercepts. Okay, so we'll finish up with a word problem where they have us graph a line just like that. Yeah, we'll do a word problem and then that's it. Yep, just sign out for me.
So Hager?
Yes,
Can I move a little closer to the keyboard?
sure. All right, so example 3. Okay, this, does everybody have example 3 on their notes? You got, okay. So it says, you're planning an awards banquet, but you need to rent tables, and there's 2 types of tables you can rent. Okay, you can get small tables and large tables. And they tell you the formula that you're going to use is right here. Okay, you have to get enough tables to seat 180 people. Okay? So that's where the 180 comes from. As far as how did they figure this formula out, you don't really need to know that right now. Okay, they're giving you the formula, you just have to use it. Okay, in the next chapter, you're going to have to know how do you figure this formula out on your own. Okay, but for now you don't. All right, so there's our formula. It says x is the number of small tables, y is the number of large tables. Okay, first thing they want us to do is graph the equation and interpret what the intercepts mean. Okay, since this is a word problem, the intercepts actually mean something in terms of the problem. It has to do with people and tables. All right, so let's find our intercepts, and then we can decide about how to graph it, because I think this is going to be some bigger numbers. So maybe we're going to have to go by 2s or 3s on our graph. All right, so let's start with our part A. Okay, so you got a little bit of space in here. What I'm going to do is just label what I'm doing. So I'm going to do part A. Okay, let's start with the x-intercept. Dominic, how do I find the x-intercept? Well, what number, you got to plug a number in. Do you remember the number you got to plug in? Not sure? You can help them out? Shannon?
0.
Yep, you got to plug in 0. And where do you plug it in?
Plug it in for y.
Plug it in for the y. Good. Okay, so let's do that. Plug in 0 for y. So we're going to have 6x plus 10, and we're going to fill in what for y? 0. So plus 10 times 0. And what is this equation equal to? That's the number of people. Okay. What's 10 times 0?
0.
0. 6 times x equals 180. What's my last step?
Divide 6 on both sides.
Yep. Divide both sides by 6. Just use our calculator, see what we get.
30.
Yep, we get 30. Now, before I graph that, I'm going to find my y-intercept because I know if I just go by ones, I don't have a graph paper big enough. So let's get the y-intercept first. And then I'll decide maybe I need to go by 5s, okay, on my graph. Okay, we'll see. Okay, how do you get the y-intercept?
You make the x a 0.
Yep, make the x a 0. So 6 times 0 plus what's going to come next?
10y.
10y, and that's equal to 180. 6 times 0, it gives me 0. 10y equals 180, my last step. Yeah, kid? Good job. Divide by 10. Divide by 10. And if we need our calculator, we can do that. But yeah, you'll just get 18. Okay, so I got some bigger numbers for my intercepts, so I can't go by ones unless I had a graph paper that went all the way to 30. So
Use the inches you get?
what could I go by?
5.
Yeah, let's go by 5s.
No, you can't go by 5. You're 18.
That's okay, so what we're going to do is we'll just be in the middle of 2 lines. Okay, if you go by 5s, because if I go by
Go by
2s,
3s.
that's not enough. Yeah, we could go by 3s. Sure. Yeah, if you want to do that, if we go by 3s, then the answers are going to land on nice numbers. Okay, so I've got 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Now, you don't have to number everything. If you just number the first 3 or 4, I can see what you're going by. But if you want to number them all, in general, Mr. Ray and I aren't going to give you ones that go much bigger than like 30. Okay, so you're not going to have to do your numbering up too high. So what's my x-intercept? It's 30. And how do I graph it? Where do I put the 30? It's the x-intercept. So where does that go? On the, Shannon?
On the right.
Okay, on which axis? Yeah. The x-intercept is 30, so put a dot on 30. Okay, what about my y-intercept? 18. Now, this line we're about to draw, it has to do with the word problem. Could I have, what is x again? Is that the number of, what does it say x is on your word problem?
Number of small.
Could I have negative small tables? No. So can't have negatives on the x. How about on the y? Can I have negative large tables? No. So because x and y can't be negative, draw your line just like that. Now, what that line represents is different combinations of tables you could rent to seat 180 people. What does this one represent? That's the y-intercept. 0, 18. Think about what's y again? It's the, looking at that word problem, what does it say on your sheet? It's the number of large tables. Yep. So what does this point represent? Or actually, you know what? Start with this. What are the coordinates of this point? About 80? What are the coordinates of this point?
0, 18.
0, 18. So x represents the number of small tables. Y represents the number of large tables. So what would this point mean in terms of our word problem if you're going to rent tables for this event? And x is 0 and y is 18. Well, let's go through it again. What does x mean? X is small number of small tables. All right. What's y? Number of large tables. So what does this coordinate mean in our word problem? 0, 18. Think about it in terms of the number of tables you're renting.
You're not going to get any small, so you're going to get 18 large.
Exactly. This point right here means one way to seat 180 people at whatever event this is. You could say, you know what, I'm not going to get any small tables. I'm going to just get 18 large tables. Because remember, how many people fit at a large table in this problem? 10, right? You can fit 10 people at a large table. So if you got 18 large tables and 10 people can fit at each table, that would seat 180 people. Okay, so that's the meaning of the y-intercept. So the y-intercept means we rent 0 small tables and 18 large tables. Now that's not the only way you can seat 180 people. Okay? Another way to do it is right here. What's the coordinates of that point?
0 and 0. Wait, 0 and 30.
Careful, not 0, 30. Marissa? 30, comma 0. So what does this point mean in our word problem in terms of the number of tables we're renting? Natalie? What does this point mean? We get 30 small tables and 0 large. Okay, so the x-intercept means that we're going to rent 30 small tables. X-intercept means we rent 30 small tables and 0 large tables. If you can fit 6 people at a small table, 30 tables of 6 people, that would seat 180 people. In fact, any point along this line is a combination of tables you could rent. Right? So that's part B. It says, find 4 possible solutions to this problem. Okay? Here's 2. If you want to seat 180 people, you could do just 18 large tables, no small, or you could do 30 small tables and no large. Okay? If I make it a little bigger, does anybody see what looks like another combination of large and small tables you could rent? Let's see if let's just find one more. So I need a coordinate of a point somewhere along this line.
Let's see, 15 for x,
Yeah, it looks like 15 for x, yeah,
and 9 for y.
and 9 for y. So what does this point mean? If you wanted to seat 180 people, what does 15 comma 9 mean? You're going to get how many small tables? 15 small tables, and how many large? 9. That's another way to seat 180 people. Get 15 small tables, and then get 9 large tables. Okay? So for part B, it said to find 4 different. Well, we already have 2. Okay, we have that one and that one from part A. And I'm just going to do a third one. Okay, I'm not going to do a fourth one. Okay, but I could do more if I wanted more. Okay. So 15 small and 9 large. So we could rent 15 small, 9 large. Let's double check just to make sure that that would seat 180 people. How many people fit at a small table? 6 people, and if we had 15 tables with 6 people on each table, that's 90. How many people fit at a large table? 10. So if we had 9 large tables, 10 people on each table, 90 and 90 adds to 180. Okay, so there's a lot of different combinations you could get to seat exactly 180 people. Okay, any questions on that one? All right, so the last one, pretty much the same kind of problem. We're not going to graph this one. I just want to do this together, okay? So it says graph the equation. All I want to do is interpret the intercepts. Okay, so it says suppose you're gonna rent tables from a different company, and you could model the situation with this equation. Don't worry how they got this equation. Just that's the equation. All right, let's find our x-intercept first. Babe, do you remember what number you plug in to find the x-intercept? 0 for? Perfect. 0 for y. Okay. And Ariel, what's 6 times 0?
0.
That's gone. And what's my last step to find my x-intercept? Divide by 4. Okay, so I get 180. Divide by 4. If I was going to graph it this time, I think I'd have to make my graph even bigger. Probably go by 5s. Okay, so my x-intercept is 45. Okay, in a minute, I want to interpret what that means. Y-intercept.
Do we have more work to do after this?
This is our last one. Okay, what's my y-intercept? How do I find the y-intercept? Put 0 for x. 4 times 0 plus what comes next? 6 y equals 180. 4 times 0. 0. That's always going to happen. All right. 6y equals 180. Last step. Divide by 6. Divide by 6. I think we just did that in the last problem. Right? What was 180 divided by 6? It was 30. All right, so if x is the number of small tables and y is large, x is small, y is large, what does this x-intercept mean? Okay, and the coordinates, remember, it would be like this. That's where it would cross the x-axis.
45
So this means 45 small tables. And how many large? 0. Okay, anytime you find one of the intercepts, one of the numbers is 0. All right. And what would the coordinate be for the y-intercept? Yes, 0, 30, right? Because you're going up 30 units. What does this mean? Yeah, this means you're not going to get any small tables. You're just going to get 30 large tables. All right. And if we were to graph that, just like we did the last one, you could find other dots that are on that line. What makes it a little tough when you graph it is sometimes some of your dots might be in between lines, right? So if you said to me, what's the coordinate for, even if I make this bigger, let's say like right here. Well, I can tell it's probably 24 of one type of table, but I can't tell if it's 4 of another type of table or 5. It's probably closer to 4, but it's kind of hard for me to tell because it doesn't lie on a nice like grid line. Okay? All right, so any questions on that? All right. So couple quick reminders. Homework tonight, it's going to be a worksheet on 3.4. Last week before progress reports close. If you have anything you got to get it in by Friday. Friday is a half day. Okay, you guys will have this period as the last period on Friday. Because Friday is a half day, we're going to do our test on Thursday. And then on Friday, we'll just do an MCAS question.
That's it.